Let's go through a quick example of how to apply regression anatomy using one of the problems from the problem set that's due on Tuesday the 19th next week in Econ 173. This is problem number 1A. In this problem you're given a table of means and some covariances for several variables. These are made up data, but they're reasonable values. And what we're going to do is go through and try to calculate some regression coefficients using regression anatomy. So here's the idea. We're going to try to regress the log of earnings on age and education, and we need to find the OLS coefficients. So let's think about how to do that. Well, we're going to use regression anatomy, and we're going to start with beta 1, which is the coefficient on age. And anytime we use regression anatomy, we start with an auxiliary regression, which represents the regression of the variable of interest, the regressor, age, on all the other regressors. And in this case, there's only one other one, which is the education variable. So here it is. This is the auxiliary regression right here, age as a function of education, and F represents the residuals from that regression. Now what we're going to do is obtain those residuals, and we're going to call that age squiggle. That's the same as F. And then we're going to regress log earnings on the residuals to get beta 1. And that's the whole regression anatomy idea. So let's get started. We're going to use the usual formulas first of all to find the coefficients for the auxiliary regression. So the slope coefficient, pi 1, is of course the covariance of the two variables over the variance of the x variable, which is education in this case, and plugging in the numbers that we have from the table, you obtain that the slope is negative 0.125, and then we can use the fact that the regression always runs through the means of the variables to back out the intercept term pi 0 for the auxiliary regression, and plugging in the mean numbers and our estimate of pi 1, the slope, we get an intercept of 31.5. So now we've got the auxiliary regression all estimated using the usual rules for simple regression coefficients. And there we go. So the residuals, which is what we need for regression anatomy from this auxiliary first stage regression, our age squiggle is equal to the age variable itself minus the predicted value of age using the regression coefficients, which is in parentheses there. Then, applying regression anatomy, we have the basic regression anatomy formula for the slope, beta 1, and again that's going to be the slope of a simple regression of the y variable log earnings on the residual from the first stage auxiliary regression, which is age squiggle. So we use the usual formula, covariance of the y and the x divided by the variance of the x to obtain beta 1. So now it's just a matter of kind of plugging and doing some algebra to get the answer. So we're going to calculate the numerator and the denominator and put it all together. So here we go. We've got the numerators, this covariance of log earning and the residuals from the auxiliary regression on age. And so we're going to plug in that formula right there for what we got for the regression residuals. And applying the rules of covariance, we can distribute the covariance across the components. Of course, the covariance with any constant term, such as this intercept, is going to be 0. And so plugging in the various values that come from the table and our regression coefficients, we get that that's the covariance. That's the numerator. The denominator is the variance of the residual from the first stage auxiliary regression. We use the rules of variance, and you have to bear in mind that the variance of this sum is going to be, which is the residual, is going to be the variance of age plus the coefficient squared on the variance of education. And then we have to bear in mind that also a variance can depend on the covariance of the two variables, and in this case they do covary, so we've got to use that formula. That's 2 times the coefficient on the first variance plus the second variance variable, and doing all of that gets us finally to the end product, which is 119.875. You can see that the variance of the residual for the auxiliary regression is really dominated by the variance of the age variable itself, which is to say that in this regression the education variable is not really helping predict the age in the sample very much, and why would it really? So we end up then plugging this all back in. We put the covariance in the numerator there. We put the variance of the x variable in the denominator there, and we get that beta 1, which recall is the slope coefficient on age in the earnings regression, is 0.0136. So in this little data set, one more year of age is associated with an increase in earnings of about 1.4%, holding education constant. Now I'm not going to work through the rest of the problem because you can see that it's just going to kind of work the other way around for beta 2. So to do the rest of this problem, you're going to have to go through all the same steps, of course reversing the 1 and 2 to get beta 2, the coefficient on education, using initially the correct auxiliary regression and working through all the same steps I just did. And then once you have beta 1 and beta 2, finding the intercept for that regression is trivial because it's, again, uses the rule that it passes through the means of the x variables. And so that's going to be all based on information that you'll have once you find what beta 2 is. And voila, you are done. And that's how we can apply regression anatomy to get coefficients for a multiple regression.